Hello everyone, this is my presentation on saltwater intrusion in the Salinas Valley Water Basin. My name is Brian Baker and this is for EVSP 501, a part of American Military University. Saltwater has continued to move inland, threatening the Salinas Valley Water Basin. Saltwater intrusion occurs by many ways, including the lateral encroachment from coastal water as well as the vertical movement of saltwater near discharging wells. The issue of saltwater intrusion is rather complex, so to simplify that, we're going to look at it in terms of three things, that being saltwater, freshwater, and wells. Here's a picture of the Salinas Valley Water Basin in its entirety. As you can see, it's rather large and stretches from the top of the county all the way to the bottom. We're going to be focusing on the 140 and 400 foot aquifers shown at the top of the map touching the Monterey Bay. Here we have two maps showing the current intrusion status of both the 180 and 400 foot aquifer. Take notice on the right of the islands appearing on the 400 foot aquifer map. These islands are indicative of vertical movement of intrusion between the two aquifers. Our vision statement is successful management of the Salinas Valley Water Basin to stop saltwater intrusion and secure sustainable water basin health by 2032. Here we have a list of our management alternatives. Our first alternative would be to do nothing. The failure marker for this plan would be complete salinization. All wells would measure greater than 500 milligrams a liter. Our second option is to utilize a recharge system or a barrier. A failure marker for this would be no improvement to aquifer water availability. Levels of available water will continue to drop. More than a 2% drop in water availability would indicate a need for a change. A success marker would be a minimum of a 2% increase in water levels available. Our third option would be the utilization of a recharge system as well as managing wells specifically in no new well sites. We would also close abandoned wells and limit pumping at all levels. A failure marker would be that we would see continued intrusion, greater than a 5% increase in wells measuring 500 milligrams per liter or greater, and the appearance of more islands indicating further vertical movement between the aquifers. A success marker would be that we would have decreased levels of intrusion within the 180 and 400 foot aquifers. A minimum goal would be a 5% reduction in areas measuring 500 milligrams per liter. Alternative 1, the option of doing nothing and taking the business as normal approach, poses a high risk level. The consequence of a possible total loss of use of an aquifer is severe. It also poses an increased risk of contaminating neighboring subbasins. Alternative 2, the use of a recharge well or system and/or barriers. The risk here is medium to high. It also poses a cost concern. This method can be extremely costly depending on the method used. Worst case scenario would be that the high cost of implementation is not worth the small levels of abatement. Recharge wells also rely heavily on the availability of excess water to revert back into the aquifer, and current drought conditions and the issue of saltwater intrusion limit this amount of excess water available for this option. Alternative 3, the utilization of a recharge system as well as well management and restrictions on water. The risk here is lower than our other two alternatives, but cost concerns still remain prevalent. This multifaceted approach increases the chances of success by not investing strictly in one method to reduce intrusion. And this is why this method is our preferred method in addressing the issue of saltwater intrusion. Finally, to note, in conjunction with the listed alternatives, that these prior alternatives would need to be met with some sort of restriction on pumping. A pricing method to address overpumping could be explored. A possible tax as a penalty for overpumping could help reduce saltwater intrusion by reducing the amount of pumping. Also, the variability that weather will produce should be noted. As I mentioned earlier, that recharge systems often rely on excess water, and we currently just do not have a lot of excess water, so this is something to take into consideration. And thank you guys for listening to my presentation, and please feel free to comment with any recommendations or concerns.